and welcome back to our First Flight kickoff streams. My name is Jess, and today we have another exciting project for you to dive into and use to improve your security auditing skills. These contests are designed as an opportunity for you to practice what you've learnt over on Updraft and to prepare yourself for a real competitive audit. Now, we have some really exciting competitive audits on the CodeHawks platform at the moment. We've got Alchemix Live, and there is over $160 per line of code in that contest. We have another contest launching at midday today for Quant AMM. So we are going to be doing a live stream later today as well for that one. But if you are a beginner and you're a little bit nervous about diving into those big contests, then the First Flights are a great place to practice what you've learned on Updraft, prepare for real contests by reviewing code bases, getting to grips with how you can get familiar with a code base and learn how to make submissions ahead of actually going into competitive audits and competing for some of those prize pools. So they are a brilliant way to start. And as I said, we've got some big contests on CodeHawks at the moment, and we have some pretty big ones coming in January as well. So make sure to stay tuned for that and spend some time learning these lessons over the next couple of weeks in preparation for those. Now, as always, if you have any questions about the repo that we're about to discuss, put your questions in the live chat and we will answer them at the end of today's stream. If you have any questions later on as well, then head over to our Discord. The link is in today's description. We'll answer all of the questions there as well. If you're having any issues running the tests or building the project, we can answer those there and help you get set up and start to properly review this code base. Now, let's get into what this First Flight is. So we do these First Flights every other week, and this week's is Christmas themed. So we are looking at a Christmas dinner repo. Now, this repo was actually contributed by a member of our community. So thank you very much if that was you and you are listening. This contract is, we can pull this up to learn a little bit more about what this is and what we're going to be reviewing this time around. So let's do a little introduction. This contract is designed as a modified FundMe. It is supposed to sign up participants for a social Christmas dinner or any other dinner while collecting payments for signing up. We try to address the following problems in the organization of such events, such as funding security and overall organization. So this code base is intended to be used to organize a Christmas dinner a little bit better, have participants pay as soon as they agree to attending the Christmas dinner, and allow those funds to be used by the host. They can also decide, actually, I can't make it anymore. Let me have a refund up until a certain point. So there are a couple of different functionalities within this code base that we are going to be reviewing today and walking through. As I said, if you have any questions, then do just pop them in the live chat and we will answer them at the end of today's stream. Now, first of all, let's talk through how to get ourselves set up. So first of all, we need to go to codehawks.cyfrint.io. And if you go to the First Flights tab here, you can see all of the different First Flight contests we've had on the CodeHawks platform. Also, if you do have some extra time over Christmas and you want to do a little bit more research, there's no problem with going back into previous contests, reviewing those code bases, seeing what you can find, and then looking at the findings and seeing what you've missed. That's a good way to learn as well. But at the moment, we have the Christmas dinner contest live. It will be live until next Thursday, which is Boxing Day. So you have a week now to submit vulnerabilities that are present within this protocol. So what we need to do to get set up is we go into the First Flight. You can click View Repo here to open the repo. We can copy the GitHub URL here to take to our VS Code. So once we've got that all set up, we can go to getting started, and we've got all the instructions here on how to set this up. Now, I am actually all set up within my VS Code. So let's pull this up and get started, review this code base and see what we've got in store for this week. What you can also do actually before we move on to this is take a look at the different actors within the contest details as well on the CodeHawks platform to give us a little bit of an idea of how the protocol is supposed to be used. So the contract is designed as a modified FundMe. It is supposed to sign up participants for a social Christmas dinner or any other dinner while collecting payments for signing up. We try to address the following problems in the organization of such events: funding security and organization. So for funding security, organizing a social event is tough. People often say we will attend, but take forever to pay their share. With our Christmas dinner contract, we directly force the attendees to pay upon signing up so the host can plan properly, knowing the total budget after deadline. And the other problem is the organization. So through funding security, hosts will have a way higher time have a way easier time to arrange the event which fits the given budget, no backseas. So there are three different actors within this protocol. We have the host, we have the participant, and we have the funder. For the host, the person doing the organization of the event is the host. Now they are the receiver of the funds by the end of the deadline. They are privileged, they have a privileged role which can be handed over to the participant by the current host. We also have the participants in this protocol, so attendees of the event which provided some sort of funding. A participant can become a new host and can continue sending money as generous donations. They can sign up friends and can become funder. And finally, the final actor is a funder. So a former participant which left their funds in the contractor's donation but cannot attend the event. The funder can become a participant again before the deadline ends. So there's three different actors there: the host that's collecting all the funds, the participants that have paid and are turning up, and the funders who have paid but can no longer make it. So let's talk through the contract then on a little bit more of a more technical level to understand what's going on here and what we're really looking at. Now, this is being formatted very, very nicely, so it's very clear throughout what we're looking at here. There are a couple of custom errors at the top here. We've got 5 of those, and we've got some custom events as well. So we should be emitting events every time there's a new host, there's a new sign up, there's a contribution, a participant has changed, if there's someone's been refunded, or the deadline has been set. In any of these occasions, we should be emitting one of those events there at the top. Next, we have our immutables. So these are the variables that cannot be changed. We have got the addresses for wrapped Bitcoin, wrapped ETH, and USDC. Now, they will all be defined within our constructor in just a second. Before we get to those, though, we have some state variables as well. So we have the host's address. We have the deadline, which is a uint 256. We've got the deadline. We have the locked variable. We will be looking at the use of all these variables in just a second, but I think these mappings are important to review. So we have a participant mapping that takes a user's address and returns true or false if they are a participant or not. We also have a balance mapping. Now, this is a double mapping. So we're looking at a user, we're looking at a token, and we're looking at the balance that that user has deposited of that token. Third, we have Ether balance. So we're looking at a user's Ether balance. And finally, we are looking at whitelisted addresses. So we can put a token address in here. And if it's either wrapped Bitcoin, wrapped Ethereum, or USDC, it will return true. And if it's none of those whitelisted tokens, it will return false. And you can see that those have been whitelisted within our constructor down here. And let me make this a little bit bigger. Hopefully this is a little bit clearer. Let's close out the terminal and pull this up. So within our constructor, we're taking an address for wrapped Bitcoin, wrapped ETH, and USDC, and we are whitelisting those through that mapping there. So you can see all of those have been set to true. The other thing that's been done in this constructor is we have assigned the host variable to be the message sender. So the deployer of this contract is the person that is going to be the host for this Christmas dinner. Of course, as mentioned, it can be changed later on, but we will get into that in just a second. Moving on, we have set some modifiers within this contract as well. So we've got 3 different modifiers here. We've got one that checks that only the host can execute that function. So we're looking at the message sender. If it's not the host, the function will revert. We also have a modifier which is before deadline to make sure that the function is being called before the deadline has hit. And finally, we've got a non-reentrant modifier there as well. So these modifiers will be assigned to different functions throughout this protocol, and it will be run before the function starts to make sure that the conditions are true. So let's get into the actual functions here, see what's going on. First of all, we have a couple of view functions, nice and easy. So we're looking at the get host function. This will return the address of the host. And we've got a get participation status function as well. So this takes an address and then it uses the participant mapping that we reviewed up here to see if that address is a participant, user is a participant or not. So it will return true if the address belongs to a participant, and false if the address is not a participant. So there's the view functions there, nice and easy. Next, we're moving on to the state changing external functions here. Now let's take a look at what the developer has written here. So handles the deposit logic, supposed to only let deposits of whitelisted tokens happen. So that's one thing we want to check. We want to make sure only whitelisted tokens can be deposited. Supposed to not accept deposits after the deadline, so we want to check for that as well. Allows multiple deposits of a user as generous extra contribution. So we want to make sure that people can deposit multiple times. Next, we have allows a user to sign up other users. So we want to check that that can happen. We assume that no weird ERC20s or any ERC20s outside of the whitelisted tokens need to be handled. So we are assuming that only wrapped Bitcoin, wrapped Ethereum, or USDC is being deposited within this function. We are assuming general trust relationship between the users of this contract. And finally, this function should not allow signing up with Ether. For Ether signups, use receive function there. Now, finally, before we get into the actual function, we are saying that there are two parameters here: the token the user wishes to deposit and the amount of that token that they would like to contribute. So let's take a look at this function then. We've got a simple deposit function here. As I said, we're taking those two parameters. It is external, and we have that before deadline modifier here. So with this here within this function, it means that we are calling this. What was the modifier looking at before deadline? So we are calling this modifier before the function starts. So we're checking that the current block timestamp is higher than the deadline. If it is, then we want to revert. We want to make sure then it's less than, because that means we are before the deadline, and therefore people can still deposit and sign up for their Christmas dinner. So once that check has been done, we have a couple of other checks to do as well. We want to make sure that the token that's being deposited has been whitelisted. This is using the mapping that we looked at earlier in the stream. So quickly going up to the top here, you can see that we have a whitelisted mapping, and this takes an address and returns true or false. So if we have wrapped Bitcoin, it's going to be returned as true. If we have wrapped Ethereum, it's true. And if it's USDC, it is true. So any of those token addresses will return true through this mapping, making sure the user is depositing a whitelisted token. So now we are up to here. So what have we got next? We've got the participant message sender. So we're looking at the next mapping that we have up at the top. Participant here, this is a mapping that takes a user address and returns true or false. If the user is a participant, it's true, and if not, it is false. If we go down to the function once again, you can see that we're taking the message sender, so the person that's calling the function, and saying, are you a participant, yes or no? If you are a participant, then we'll look at your balance. So we're looking at that double mapping that we reviewed earlier. We've got the balance of the message sender for the specific token that they're depositing this time around, and we're increasing the user's balance for that token. So let's say, for example, a user is depositing for the first time. They have Well, actually, no, they're depositing for a second time because they're passing this check here. They've already deposited 10 wrapped Ethereum into the contract, and now they're depositing some more, a contribution. If they have the wrapped Ethereum token address here and they are depositing 5 more, we will pass all of these checks because we are before the deadline and it's a whitelisted token. We will then pass this check because it is already a participant. And then we come to this line here. So the balance of the message sender, the user, for wrapped Ethereum will currently be 10. And here we are adding the new amount. So we're adding 5. So this should now run as 15. Next, we are doing the safe transfer. So we are transferring the token from the message sender, from the function caller, to the contract address for the given amount stated within that parameter. Once that is done, we are going to emit the generous additional contribution function event that is going to be emitted there. And you can see that clearly. Now, the other scenario is that the user is not yet a participant, and this condition here is returning false. That mapping is false. Then we run into this else statement here. So in the else statement, you can see that we are changing the participant status from false to true. So this is a mapping that's changing. The message sender is going to now return true within the participant mapping. We are then going to increase the balance from 0 to whatever they have deposited through this deposit function this time around. We're then going to do the same thing again. We are going to do a safe transfer from the user calling the function to the contract address for the set amount that they've deposited. And we are going to emit a event here that says, look, we've got a new sign up. This is the user. This is the amount they've deposited. And we are going to change the participant status, the participation status to true here within this function. So deposit, that was very long-winded. We went into a lot of detail there. Essentially, we're going to deposit a whitelisted token. We are going to do that before the deadline, and we are going to set an amount. If you're not yet a participant, you will become one. And if you are a participant, you'll be doing a contribution, a donation. Moving on to the next function here, we have the refund function. So the refund function is if for people who do not want to attend the event anymore, it pays out all underlying assets, reentrancy safe via mutex lock. Therefore, CEI does not necessarily need to be followed. So let's take a look at this function here. It's called refund. It is external. We've got the non-reentrant modifier on there, and we've got the before deadline modifier on there. Again, just quickly coming and taking a look at this. These are the two modifiers that we are going to run prior to executing this function because of those keywords being introduced during the function creation. So if we have a look at the refund function, what we are going to do is we are going to make the message sender's address payable. We are going to refund ERC20 tokens that have been deposited by that player, and we are going to refund ETH deposited by that player before emitting the refunded message sender event that has been created. Now, this, once again, can only be done before the deadline, and we've got that non-reentrant check there as well. Moving on to the next function within this first rights, we have the change participation status function. So this is an external function, and this supports not attending without a refund, also allows many changes of mind, but strictly enforces that false cannot be changed to true after the deadline. So, change participation status. If the participant wants to change their status and so if the user is a participant, this will return true, and we can change that to false. Now, the next condition is if the user is not a participant from this exclamation mark that's put at the start here, and we are executing this function prior to the deadline, then we can change the participant status to true. So if we are before the deadline and we are not a participant yet, we can become a participant. Finally, if we are looking at this and neither of these first conditions are true, so the user is not a participant, but it's after the deadline, we would revert and we would say, look, we are beyond the deadline now. It's too late to become a participant. Finally, once this is all done, we omit the change participation event and we put the message sender and the participant status within that event as well. Next, let's move on to the privileged external functions. These are the extensions that are executed by the host only. So changes the host of the, so there are a couple of functions here. We've got the change host function, we've got the set deadline function, withdraw function, and the receive function. So let's run through all of these. The change host function specifically changes the host of the event, must be changeable multiple times to avoid spontaneous cancellation issues of the host. The host must attend the event. We assume that if the host changes after the deadline, the new host has an agreement with the old host to make the event work. So we take one parameter for this function, and it is the new host parameter, an arbitrary user, which is a participant. So we can only make a current participant a host for the dinner. Taking a look at the change host function, we are going to take an address as a parameter. It's limited to only the host. This is another modifier, as we saw earlier here. Only host, make sure that the message caller is equal to the host address that was determined and set to the deployer through the constructor. If we come back down to where we are here, you can see that if the user is not a participant, they cannot become the host yet, and we revert using this custom error. Now, if that is not true and the user is a participant, then we can change the host variable to hold the parameter here, the parameter address, and set the host to be this user instead, and then emit an event to say, look, there's a new host here. Next, we have the set deadline function. This changes the deadline until which attendees can sign up. Any sign up or refund after the deadline should never be possible to assure proper planning for the attendees. So once the deadline is hit, no refunds can be given and no new users can come. We have one parameter for this function, and this is days, it's UN256, number in days until when the host has to know who attends. So if we call this function, only the host can call this function because, again, we have that only host modifier, and they have a parameter of days. If the deadline's set, then we revert and we use this message here. But if the deadline is not yet set, then we are going to take the current block timestamp. We're going to add the number of days that have been input here in this parameter, and we are going to then emit an event that says, look, this is the deadline for this Christmas dinner. Next, we are moving on to a withdraw function. So this function withdraws all tokens from the contract into the host wallet to facilitate the event. We do not have reentrancy considerations since this function is supposed to sweep the contract anyway. So this is a function that can only be called by the host. We've got that modifier once again. There are no parameters here, and there are 3 easy steps that are going to be taken here. So we're going to get the host address here, and then we are going to withdraw the contracts wrapped Ethereum, wrapped Bitcoin, and USDC to that address, the host's address. So we're going to do a safe transfer to the host from the current contract, and we're going to do that 3 times. Now, that function will only be used after the deadline has been set to start funding the dinner. Next, we have functions to handle Ether deposits. So we'll just have the one here. This is the standard receive function, handles Ether signups. Users sending Ether to this contract will still be tracked with their balances and participation status. So it's saying, look, although we have those whitelisted wrapped Bitcoin, wrapped Ethereum, and USDC addresses, we can also accept Ether for this Christmas dinner. So this is the function that handles that. Simple receive function, external, it's payable when people deposit money for the Christmas dinner. Their Ether balance increases through that mapping that tracks it, and we're going to increase the value by the amount that's been sent through this function. Then we're going to emit new sign up with the user's address, the user's deposited value, and we're going to set the final parameter to true. Now, if we take a look at new sign up and we say, what is this event? Let's quickly remember. The new event has the address indexed. We have the amount they deposited and the Boolean, whether they are a sign up or not, a successful sign up or not. And that is set to true within our function. So that event is emitted. And we're now handling Ether deposits as well, which is great. Moving on to the internal functions now, just 2 more functions to go. We've got the refund ERC20 function. So ERC20 withdrawal of all user funds, no concern for reentrancy since refund uses a mutex lock, param 2 payable address passed from refund. So this is an internal function, and this function is called within the refund function. So this is when we said earlier, when the refund function is called, it's for people that don't want to attend the event anymore. It pays out the underlying assets to those users if it's called before the deadline. Now, they want to refund all the ERC20 tokens and Ethereum that have been deposited by those users. And these are the 2 functions that do that here. So we are going to do a safe transfer of the wrapped Ethereum, of the wrapped Bitcoin, and of the wrapped USDC to the user's address when they call that refund function. So we've got safe transfer from the to the user from the contract for their specific balances, and then we are going to set all of their balances to 0. So this is the double mapping that we saw earlier in the contract. We are going to get the balances for the address for the specific token and set those to 0. Now we're going to do a similar transaction for the Ethereum that they've deposited as well. Again, this is an internal function that has been called only within the refund function discussed earlier. We are going to take a look at the amount of Ether that the user has deposited. We are going to do a transfer to that user to give them their funds back. And we are going to set their Ether balance to 0 so that they can't refund themselves multiple times. So there are all the functions within the contract. Just to quickly run through how a person or user would interact with this. As we ran through all those functions in a little bit of detail, and I want to kind of zoom out a little bit and look at this a little bit more clearly. What we have here is we have a host deciding they want to have a Christmas dinner. They organize this by getting this contract and deploying it with some variables within the constructor. So they are going to set a wrapped Bitcoin address, a wrapped Ethereum address, and a wrapped USDC address. Now, the deployer will automatically become the host, and they can start planning their Christmas dinner. They can invite participants to join, and these participants will join by depositing those wrapped Bitcoin, wrapped Ethereum, and USDC with the deposit function, or with the receive function if they want to deposit Ether. Now, once they call this deposit function, they will become a participant through that mapping discussed at the top. They will deposit one of those tokens with a specific amount before the deadline. And we will have that happen multiple times. Now, the deadline will be set by the host through the set deadline function. And then time will pass, more participants will enter. Some participants may decide, actually, we can't attend this anymore. If it's before the deadline, they can get a refund. So they go to the refund function, which is here, and they can say, look, I can't attend this dinner anymore. I'd like a refund. They call this function. It calls 2 internal functions, and it sends back any of the wrapped Bitcoin, wrapped Ethereum, USDC, or Ether that has been sent by that user. And that user is no longer a participant. Now, others may decide, actually, this is really exciting. We're going to have a lovely Christmas dinner. Let's contribute some more funds to the host. So they can do that by going to the deposit function and just depositing some more. It will get added to their balances, and that is handled all within the deposit function. Now, some more time passes and we go past the deadline. Now, once the deadline is passed, no users can get refunds. They can no longer attend the event if they would like to, but no refunds will be given. The host can withdraw the funds that have been put within the contract, and they can go out and buy all of their food and make a lovely turkey dinner. So that's how the protocol is intended to work. There are a couple of vulnerabilities hidden within here, and this is where we hand over to you to find those vulnerabilities. So, I mean, I've spotted a couple throughout talking through those functions. The advice that I would give as somebody looking to get started in these first flights and learn a little bit more is to look at the intended functionality and compare that to what the contract is actually doing. A lot of the time, that is how you can find your first vulnerabilities. Look at all of the descriptions, look at the different actors, and look at what those actors can actually do. See if people are doing something that they shouldn't be able to do, and there's some vulnerabilities hidden in there. So that was actually quite a detailed deep dive into the first flight. Usually these streams take about 10-15 minutes, but we have had a half-hour discussion about this contract. So hopefully that was detailed and you have an understanding of how this code base can work, so you can dive straight in and find some of those vulnerabilities. So it looks like there weren't any questions in the chat. We've got one person saying, got up early just for this. Amazing. Thank you very much. If you do have any questions, then head over to the Discord and ask the questions. We have a channel specifically for this first flight contest. So any questions about this protocol, head over to there. If you don't have any questions as well, I would recommend just being in there, because you may see some other people asking questions and it may help lead you to find some of those vulnerabilities. As we've said, this is just a contest to practice your skills. So there's no harm in learning from each other, discussing the code base through. The more people that can find vulnerabilities, the more people that are prepared to move forwards into those real competitive audits over on CodeHawks. Now, just quickly looking at CodeHawks, we've got the Alchemix contest live at the moment. That ends on Monday. As I said at the start, we've got 16,653 OP in this contest. Now, this contest has 253 lines of code. Last time I checked, we had over $160 per line worth of OP in that contest. So a very, very exciting one. That's one of the highest in the market, if not the highest in the market at the moment. And we have Quant AMM starting very, very soon. That is for 49,600 OP. So that's a huge, huge prize pool and a very exciting project. So we will be live again on this same channel at midday with the developers from Quant AMM to run through that code base, do a similar kind of review, to be honest, but on that real competitive audit. So if you are interested to take that step from first flights to CodeHawks, then make sure to tune back in at midday. But that's all we have time for today. So thank you very much for joining us. I hope that has helped. Once again, if you have any questions, head over to the Discord. Well, that's all from me today. So thank you very much for watching. Goodbye.